Welcome to the Explainer. So let's just dive straight into it, right? Today, we're zooming way, way out. We're leaving our everyday on-the-ground experience behind and heading right up to the grand cosmic scale to figure out how gravity actually works. I mean, think about it. Why does an apple fall straight to the ground, but the moon just stays up there in the sky? Well, back in 1687, Isaac Newton had this massive realization. He figured out that the exact same invisible force that pins us to the Earth is actually the one dictating the motion of the moon, the planets, and even our ocean tides. It is all connected.
The secret is baked right into Newton's law of universal gravitation. The equation basically tells us that the gravitational pull between any two objects relies directly on their masses. Bigger mass equals a bigger pull. Simple enough, right? But here's the catch. That force relies inversely on the distance between their centers. And man, that changes things dramatically.
To really picture how distance changes the game, think of the inverse square law like a regular can of spray paint. Just like paint spreads thinner and thinner over a much larger area when you step back from a wall, gravity does the exact same thing. If you double the distance between two objects, you don't get half the gravity. You only feel 1/4 of the force. Triple the distance, the force drops to 1/9. It fades incredibly fast. And honestly, this totally busts a really common misconception. You know how people always say astronauts are weightless up in space? Total myth. The reality is, astronauts and stuff like NASA's Swift satellite are actually in a constant state of free fall. They're definitely being pulled by Earth's gravity, but they are moving horizontally at just the right, incredibly fast speed so that the curve of their fall perfectly matches the curve of the Earth. Okay, now consider this ridiculously tiny number. 6.67 times 10 to the negative 11th. That is the universal gravitational constant, also known as Big G, which was famously measured by Henry Cavendish. This minuscule value is exactly why gravity feels so incredibly weak between small everyday objects. I mean, you literally need planet-sized masses to make gravity actually feel strong. But, science is always evolving. Newton believed gravity was this instantaneous force caused entirely by mass. But then Albert Einstein comes along and realizes, wait, gravity is actually caused by energy, and it has a strict cosmic speed limit, the speed of light. Because of this, if the sun just suddenly vanished, no way would Earth instantly fly out of its orbit. We wouldn't even feel the gravitational change for a full 8.5 minutes. Which brings us to a seriously mind-bending conclusion to wrap up this explainer. Because absolutely every single piece of mass in the universe has gravity. Well, that includes you. So think about it. What tiny, invisible gravitational forces are you exerting on the objects sitting around your room right now?